Good morning, good afternoon, good evening, wherever you are logging on in the world, and welcome to this special Infrastructure Intelligence online showcase event organised with BST Global. My name's Andy Walker. I'm the editor of Infrastructure Intelligence, and the issue we'll be looking at today is how artificial intelligence and big data will transform the architecture, engineering, and consultancy industry. Artificial intelligence, machine learning, and big data are clearly emerging technologies that are reshaping every industry today. So we're delighted to have an expert in this field in both BST Global, deploy project-based enterprise resource planning solutions for architecture, engineering, and consultancy firms around the world, but also in Hank Tran, who is BST Global's Director of Knowledge Management, who's going to discuss these issues today and talk about how you and your own firms can get the innovation journey started in your own companies. As I said, Hank is an expert in this field. He leads a team delivering business intelligence, big data, artificial intelligence, machine learning. The list is endless almost, it seems, in terms of Hank's experience. And he's got more than 30 years of it working in our sector, where he is very keen to stress that he works with clients every step of the way. And in his presentation, which you can just see on the screen here, Hank's going to examine the opportunity, your opportunity, to leverage some of these technologies in your own organizations. After Hank's finished, I'll ask him a series of questions. Do feel free to post any of your own in the chat, and we'll try and get to those too if we've got time. As always, if you're watching this not live via our YouTube channel, we know many people do, then please feel free to send in any questions to the contact details that we'll give at the end of Hank's presentation. And we'll also share those in our report, which will appear miraculously on our website this afternoon following today's event. So without further ado, let me introduce Hank Tran, BST's Global Director of Knowledge Management. Hank, the floor is yours.
Thank you, Andy, for the kind introduction. And good morning, good afternoon, and good evening for all those. Welcome, and I appreciate the opportunity to join you today. So let's start the conversation with a quick question. Why is there such an explosion in the use of AI in recent years? And that's because 30 years ago, only large companies and government sectors could afford to implement AI. Now, at that time, I was working with some of those companies launching satellites into space, capturing telemetry data along with ground systems and satellite phones data in order to predict travel patterns and provide uninterrupted cell coverages and perform fraud detection and prevention. The same satellite solution are being used today to enable your Google Maps or the maps alike and Wi-Fi on airplanes. Since then, technology has become a long way with advanced computational power, but more importantly, it is now more affordable, allowing consumers and businesses alike to enjoy the benefits of AI, such as improved safety, productivity gains, and cost savings. Now, for consumers, cars can be equipped with accident avoidance systems or using Netflix for movie recommendation. But for businesses like manufacturing, oil, and gas companies, AI is used for predictive maintenance to prevent equipment failure. Now, as of today, artificial intelligence, machine learning, and big data are changing the face of every industry, including the AEC space. So let's start by defining the term machine learning and artificial intelligence so we're all on the same page. Machine learning, or ML, is fundamentally a branch of AI. It is one method to achieve AI. Both works with small or large data sets to determine common pattern and explore differences. Now, over time, it will be able to assist in analyzing the problem and providing results faster than a human can. The difference is AI can make decisions on your behalf. So an example of AI is the popular Deep Blue, which is the AI that defeated the world chess champion in 1997. It used a method called the tree search algorithms to evaluate millions of moves at every turn. Now, AI is not just for business. Now, before we dive into more details on these trends, let's start with an easy question for this group. Now, how many of you interact with the AI on a daily basis? Surprisingly enough, we interact with AI and ML on a daily basis. For example, from using facial recognition to unlock out your phones, or to use Netflix movie recommendation and Amazon for product recommendation. Now let's now take a look at AI in the AEC industry. The same evolution happened in AEC industry. Now, when CAD or computer-aided design became mainstream in the 80s, there was not much aided in the design of buildings. CAD was simply replace manual drafting and drawings documentation. Now today, AI is taking CAD beyond its original capabilities. By using generative design, computers can generate thousands of designs which will meet all predefined goals. The architect can then refine and create the best and final solution. An example here of generative AI is the use in the Shanghai Tower. Another example of generative AI is the complex grid shell of the Singapore Jewel Changi Airport. Now, without generative AI, many of the historic free-flowing buildings of the 21st century would not have been cost-effective to design and build. Now, generative AI itself has evolved over time. Earlier application was focused on form and structure. Today, it is shifting toward other design goals with criteria such as cost, performance, sociological, and environmental metrics. Now, as we can see, the benefits to industry can be huge. AI can improve quality, reduce waste, and lower costs across the industry. These technology can also de-risk the design and build process of complex building by giving AEC firms such more confidence that project goals will be met and delivered on time. But while AI is being included in the technical application of AEC industry, the business side and its related key performance indicators or KPIs remain unchanged. So for example, revenue leakage. According to BSC Global State of the AEC Project Lifecycle Report, the revenue leakage stood at 6%. Our respondents want to cut that in half to 3%. The price here is at 3%. Utilization, according to the Clarity Report 15 years ago, utilization stood at 61.5%. 15 years later, it actually gone down to 59.9%. Now, the best of the best performance of the top 30 companies is at 74.5%. This is another price of about 15%. We all know that for every 1 percentage point increase in utilization, you take half of that percent to the bottom line. Another example is profitability. Now, according to the FCG's overview letter from winter 2021, the median profitability 15 years ago was at 11.4%. In 2021, it is estimated to be at 11.5%. Now, the best of the best top 30 again is at 26.5%. This is another price of 15%. So why, given the advancement and evolution of today's technology, why is it that things have been the same in the 15 years? Now, why can't we use today's system to achieve some of these prices? Well, it is because they are too complicated. There are multiple systems with complex workflow and used to manage and deliver a project. They also plague with disjointed data from ERP systems, procurement system, human capital management system, and the list goes on. We also know that people love spreadsheets. They use Excel to create reports, manage their projects, manage their staff, bids, risk, scope, opportunities, and the list goes on and on, spreadsheet after spreadsheet and after spreadsheet. So these systems are workflow driven, plagued with historical data and disjointed data that only offer a review project visibility. Is there a better way to improve these KPIs? Yes, by using AI, big data, and building predictive analytics. A recent study from Stanford University interviewed innovative executives from top companies such as Pepsi, Starbucks, and Volkswagen. They all believe these technology can help create innovative products and services. Also, companies such as Google, Amazon, and Microsoft are great at monetizing data and providing technologies that can help you achieve the same. So given these trends, how can AI help you better manage the projects and change the world one project at a time? Now we can use AI or ML to make our system smarter by simulating human intelligence. Now for years, we have been very process driven. We have created a system to process transactions using predefined workflow and business rules, which are subjective to human biases and don't have the ability to learn. We need to be more predictive. We need to make our system smarter and learn from data, which are the facts, and not be constrained by predefined business rules. We need to be more data-driven. We need to create machine learning and AI solution that can analyze patterns, predict outcomes, and detect anomalies in order to become predictive. And by becoming more data-driven and predictive, we can infuse AI into everyday project management to deliver project intelligence. Now, project intelligence, we use AI and machine learning to deliver predictive capabilities that will help you better manage your project. Now, I believe AI and ML would change the business intelligence landscape. We need to move from only looking at historical performance, presenting a static report dashboard, to looking forward into the future, much like using a car with live GPS, where it highlights accidents and traffic jams. For example, ML models can be employed to provide project intelligence, where the models can predict potential downward trends related to utilization or revenue leakage, as an example, and offer options for resolutions. Now, in short, today's project intelligence solutions need to be much more than just passive dashboard and reports. We need to use, again, machine learning capabilities to deliver predictive insight. And empowering your data is the key to achieving predictive capabilities. And empowering your data, I believe we need to embrace big data solution and having the right data architecture as the foundation for your AI capabilities. We need to become a data-driven consultancy. And fundamentally, there are three guiding principles for creating this foundation. First, we need to be able to unify information from multiple data sources, eliminating data silos. By using data lake technology, we can combine data from different sources with varying format and make it available for AI and ML solution for use anywhere, anytime, and across multiple surfaces. Second, secure. We need to secure data in transit, at rest, and only allow authorized user to have access to predictive outcomes. And third, we need to make the system smart. An example of making a system smart is anomaly detection. When we look at the broad-based application of Netflix and Amazon, which leverage what's called principal component analysis, or PCA. PCA might be used in the context of projects for anomaly detection. And I would touch on this in a little bit with a case study. But a quick definition on PCA. PCA looks at data from different angles to identify variance along a direction. Now, its main use is dimensionality reduction, essentially focusing on significant dimensions and ignoring insignificant ones. So how? Let's talk about how you might approach ML. First, again, we need to become a data-driven organization and treat information as an asset. We can't talk about AI without talking about data, which is the underlying foundation that is needed for AI and machine learning, but not just any data. You need quality data from multiple sources and in different format. You also need data with the appropriate signals of variability in order to increase the frequency and accuracy of your prediction. Again, I believe you can achieve this through the use of big data and having the right data architecture. Second, approach ML or AI in a phased manner. And that is predict, detect, and optimize. Now, during the prediction phase, you want to verify the predictability of the data. You want to pinpoint significant features or variables for learning and prediction. You also want to engineer new features that doesn't exist in your systems or other data sources. You want to validate your prediction using the 80-20 rule. That is, learn from 80% of the historical data, hide 20% for verification. You will likely spend quite a bit of time during the prediction phase. Now, you will discover the quality of your data and learn if it provides adequate breadth and depth. And you will also know if your data architecture can provide enough signals to drive the frequency and accuracy of your prediction. Now, during the detection phase, the goal here is to identify the causality of the outcome. We want to detect and monitor key influencers that are causing the upward or downward trend of the prediction. This is where you could implement PCA, as I mentioned earlier, along with other methods. Now, having the right data signals during this phase is essential to identifying the causality of the prediction. And finally, during the optimization phase, by understanding the causality of the outcome, we can recommend the best way to positively optimize the results. Now, let's look at an actual example of machine learning models to prevent revenue leakage, which use net labor multiplier as an indicator. This is an actual project from over 50,000 projects that we have tested against some of our clients and have consistently delivered 96 to 98% accuracy. In this example, the KPI is set at 2.8. You can set this KPI at any level that you want for the model to react. The model uses a rolling 7-day window to predict 30 days into the future. The actual transactions are represented by the green dot. The prediction is in the black line. Now, as the project progresses, the actual transactions in green dots are occurring along the predicted line. Now, you can see here it is nearly identical to the black line. The reason is because of the accuracy of the prediction. Also note at the same time, the model starts to predict the next 30 days while refining and adjusting its prediction. The model also detected 2 anomalies shown in red occurring in the month of August. As you can see, the model was able to predict the first revenue leakage represented by the blue dot, which is the actual posted revenue. And the anomalies associated with the leakage. Now, as more data is collected, the model will continue to predict and detect anomalies that cause a downward trend and continue until the project is completed. We can also see more and more anomalies occur in the red line, which is likely a representation of the project team trying to recover post-September until recover from a downward trend. And with this particular project, the team waited too long to react to the early anomalies back in August, which resulted in more revenue leakage. So the opportunity for course correction was back in August, or in this case, the impact zone, in order to prevent revenue leakage. Now, this is one project. Imagine this multiplying against your project portfolio. If you could course correct over hundreds of projects or thousands, you can actually really move the needle. Now, as you can see, machine learning models are able to learn and predict that if we follow the same path for a given project, we hit a roadblock. But by being able to predict the roadblock ahead of time and knowing the potential causes for this roadblock, we can change the trajectory of the project. That was just one example. In summary, AI or machine learning has so many capabilities to transform our project managers, project accountants, architects, and beyond. But there are so many other applications outside of this. For example, project bidding, planning and setup, resource planning and management or capacity planning, portfolio management, project building and collection. The list goes on and on. That's why we're exploring so many other options to better our solution. Now, one final thought. We have to be responsible when developing AI solution by employing ethical AI practices. For example, removing unfair bias, sensitive variables such as race, gender, religion, should be removed from the model. For example, Amazon stopped using the AI for recruiting because of keyword and gender biases. Governance allow access to only data that is specific to the use case or the model. Privacy needs to remove identifiable data, such as in healthcare, where in the United States is separate related, or GDPR data. You want to keep that in mind as well. Explainability, results should be transparent, and this is supported by fact and feature importance. And data risk, prevent security breaches by restricting access and model and data, including backdoor. Now, thank you for allowing me the opportunity to speak today. And if you have any question or request, please email my colleague Kosku at the screen above. For that, I'm going to pause and open for an open dialogue and question and answer. Andy? You're on mute, Andy.
Thanks very much indeed for that, Hank, for that fascinating overview of this developing area that is, as you said in your presentation, starting to impact on our sector. You spoke a lot there about data, and I think, particularly I sense a lot of nodding heads when you have the multiple Excel spreadsheets filling the screen, which are obviously the bane of many people's lives, in terms of data silos, multiple sources, things not being linked together. This data that you're pulling together, on this particular, using this particular approach, is it firm specific, first of all? So is it absolutely unique to the firm that you're working with? And also then, where does that data all come from? And I suppose, how do we ensure, because it's easy to talk about, we need to get away from data silos, and I'm sure many people would love to do that, but in practice, it is actually a little bit more difficult. So if you can just explore that whole data area, and how do we get it to a point where it works for us, and where we can truly be, as you described earlier, a data-driven organization?
Sure. The data should be firm specific because it describes the historical performance or the facts based on your operational and use case. So in the case of revenue leakage or utilization, that data will be firm specific and system specific. It could come from an ERP system, but also could be outside the firm, meaning that additional geographical data, if you will, or behavioral data could be combined to enrich your existing system and data in order to give you additional information that way to expand or give you broader insights into the use case that you're trying to solve at hand. Now, the other question is about the feasibility of aggregating data from different sources. And the reality is multiple systems will exist in the heterogeneous world. You always have multiple systems. What we need to do is enable either extraction of that data in a secure manner, but use data lake technology either from Amazon or Microsoft or Google, that there's standards that allows you to then export those data in a different format so that you can combine them in a very cost-effective manner using the cloud and data lake technology to combine, unify that, and put governance process in place so you can combine and join those data and use by the machine learning model. Hopefully that answered the question, Andy. You're in.
Thanks for that. I'm just too disciplined on the mute button. A couple of questions in the chat that I think we'll get to a little bit in a while. Obviously, when we're talking about projects, when we're talking about this sector, this industry, there's a lot of change going on. Projects can, sort of speed up, slow down. There are all sorts of imponderables, as we've seen over the last 2 years in particular. So how do you address issues and change outcomes, with the approach that you're talking about? Is it flexible in that way?
Yeah, it is. And you hit the key word there. The operative word is outcome. you have, and for AI and machine learning to be beneficial, it has to be outcome driven from day one. So it has to be very performance specific. It doesn't always have to translate to bottom line. It can also relate to productivity and performance, improving the individual worker, his or herself. In terms of outcome, yes, you can adjust and be very flexible. And that's why the example I showed earlier about using the threshold depends on how you measure performance. And that could be defined in terms of an index point or a percentage. And you can move that threshold as you gain performance, and the model will react based on your threshold. You have full control over the model in terms of where you want to set your benchmarking index and be realistic about it.
Just following on from that, kind of how do you keep up to date with things that are changing? Really interesting question or comment, really, that I suppose demands a bit of a response, really, from Peter Slater in the chat. And he says that when we ask Google and Microsoft how they stay current with fast-moving digital transformation, because obviously there are a lot of moving parts here, both replied that partnering and venturing is the only way to stay current. So, working together. However, Peter says, it seems that a lot of existing large organizations jump into a DIY approach as opposed to developing and partnering with up and coming smaller organizations. So, and Peter's asking, do you have a view on that? Do you have a perspective on that?
Yeah, so if you look at, it depends on the nature of the business. I can tell you government sectors and healthcare sectors or financial related sectors are often very leery of partnering with outside companies. And the reason for that, some are warranted, some are just based on fear. The warranted reason is because of intellectual properties and the nature of privacy information being leaked. We all have seen it being leaked out there. And some other companies are more than welcoming to work with large companies than partner with them. The underlying concept here is data protection and data architecture, data privacy. If you take step from day one and not just be enamored or glorified by the promise of AI, start with the fundamental foundation is, do you have a good data governance, a good data architecture? Start with that. Make sure you manage that from day one. Then it doesn't matter if you want to go into the cloud or not. But security must be the first and foremost thought from day one, including data architecture.
Thanks for that. There's another question in the chat, which I must admit, I was thinking about this when you were presenting earlier, when you were talking about bidding for projects. And it's Michael Gradua, and he asks, how can you explain, Hank, how we can use AI to optimize bidding for projects? And he's asking that question, obviously, because all companies involved in the sector do it. And potentially it'd be a good example of how we could practically apply AI and optimize outcomes. And he just says that I'm asking this as a complete AI novice, which I suppose many people watching and listening today may well be. But what's your thoughts on that? How can it be used to optimize bidding for projects? Because my ears pricked up when you mentioned that.
Yeah, great. Great question. All these are great questions. I love it. Thank you. So a quick example, say for bidding, if you look at eBay, right? The bidding for products and stuff, they implement different algorithm for that. And it probably take more than one session to explain that. Now, for the AEC industry, how it apply bidding is that several data sources, or contextually speaking, internal data, you will want to use a firm specific, your bidding history, your estimation history, as well as the win rate on your opportunities management tracking. So your CRM data and your CRM process, how have you curated and evolved that data and managed that data over time? But it also depends on the nature of what you're working on. For example, there are construction, building codes, or contract information. You want to bring that in and look at the geographical differences or sources where you conduct the bid. Might be different legal aspects. So there's different, contract data, CRM data. You can combine those and build similar model. This model may not be, there are so many models you can build. And again, it's use case specific. So that's how I would approach, is looking at just different type of data set. Your bid history, your contractor data, even you lose, if you didn't win a project, you want to mine it to see why you lost that bid, right? So all that come into combination and fed to the machine learning model. Hopefully that helps.
Yeah, I just think something on that. It reminds me, I was having a bit of a cold sweat there about something that happened. I think it was in the late 90s. This concept of, I think some clients tried to bring in some kind of auction bidding into the sector, which I know quite rightly firms weren't that happy with, because basically some clients were using it just to reverse auctioning, I think it was called. And they were basically using it just to drive down costs. Obviously, we don't want this kind of thing being used to do that. And I suppose in many ways, provided you have the right information in there in the first place and the right sort of benchmarks that people need to actually, reach in terms of bidding, then it could actually be used, could it not, to actually have a more level playing field and actually a more value-based bidding going forward. Would that be fair?
Yeah, I would agree to that. Yep.
Another question as well. Obviously, let's just say that I'm a firm that's looking at this and think, well, yeah, this could definitely help us, but I just don't know where to start, where to get going. How do you get started on this journey? What would be the first steps, apart from calling you, Hank, of course?
Yeah, great question. How to get started? Get started small. Be very outcome driven from day one. Pick the metrics that can deliver tangible result, and you can measure that from day one. For example, in the case study, some of the KPIs I mentioned that stood the same for 15 years, utilization or revenue leakage or profitabilities, if you will. I would start a very specific use case and build your model and make sure your data is governed within that specific use case and be able to measure it, test it to what I mentioned earlier, test your predictability using 80-20, so you can build trust from day one by being able to verify against historical data and hide some of that for accuracy testing, if you will.
Thanks for that. And obviously there'll be different people listening and watching this who are working on different projects. This approach, is it best for small or large projects? Is it more suitable for the smaller firm or the larger firm? Do you have any observations on that, Hank?
Yeah, I think, if you're a startup company of 2 or 3, depends on your business, it may not make sense, but by and large, AI and machine learning doesn't really differentiate between large and small firms. It's about data, right? So if you have collected enough data, either internally with your organization and outwardly facing public data or available data for purchase, you can use that. So it doesn't matter if it's a large or small firm.
You spoke about ethics earlier on, and there's an interesting question in the chat about the legal framework, the legal environment today around AI, particularly around GDPR, social responsibility issues, the concept of machines making decisions that potentially could lead to problems. What are the safeguards around that? To ensure that, basically, you were guarding against things going wrong that we maybe not be directly responsible for?
Yeah, great question. I would say for the business application globally, most of them are machine learning application and not so much AI. The application of AI will be very small. So in essence, if you start up with machine learning, I would say that no companies will trust the machine to make decisions from day one. So that's why I differentiate between AI and ML. And most companies will stay with ML. You're always going to put the human in different checkpoints or gated in order to govern and to make decision or approve the decision-making process. So I can see that, especially in financial world, there's always governance and gates for checking the different results. So I would never let the machine make decision blindly, right? I would put in gated process and have human checkpoints in place to verify the result and ultimately manage the overall process.
Just on, you mentioned there the role of the human, which I think obviously this is a people-centric, people-focused business. What would you say to those who like what you said here, and they want to go down this route, but they're also fearful that using AI potentially could mean that some of those people who are currently gainfully working in the industry might no longer be doing so because their jobs might be done, if you like, using artificial intelligence. How would you reassure that, and what would your view be around that? And maybe there's a bigger issue at stake here.
Yeah, I think that's a common or first known fear is that is it going to replace my job? I would say not really. It's going to make the job more productive. Depends how you use that. So AI, for example, can answer a lot of the issue that we have today for labor shortages. So go now find architects or engineer or principal professional engineers are often difficult to find. And if you have a lot of project and your firm is growing, if you was trying to grow, AI or machine learning will only help you become more productive and give you the opportunity to learn and focus on doing what you love to do versus the mundane task of having to do project accounting, verifying the financial stuff, or doing process governance. So that's what I would look at from a productivity gains and help you grow as you move forward in your journey.
And in terms of kind of selling this to clients as well, in your experience, are there clients in the UK and maybe elsewhere currently using AI? And if so, are they really maximizing its impact for society? Because there's a lot of talk about, you mentioned obviously those organizations, commercial organizations, massive organizations that are using AI, like Amazon and like, Google and others. And obviously, they would argue that it's for the greater good, but obviously it's for their good as well. How do we frame this so that we're actually saying to clients, actually, if you allow us to, sort of employ this approach on your projects, then, we could provide so much more value, not just to you, but to society in general. And really, I suppose, in many ways, that's what it's all about.
Yeah, so in the context of the AEC industry, you can use it to build responsible buildings, or environmentally sound and cost conscious, if you will, and safe. So AI can actually help you that. So, example, if you want to put up a building, you can use AI to measure the wind flow, if you will, and a capacity plan to maximize the use of space. So that's sort of environmentally sound. But for clients, you want to express how you can improve them from a business standpoint to move the needle over time. I mentioned earlier utilization, revenue leakage, but also from a employee satisfaction. How do you help to free up the time so that employee can work on better projects than to lock them in to work on things that really can be solved by machine learning model, for example.
And also, the other thing that I think people would look at this, they would think, well, what about cost? Doesn't this approach cost, isn't it going to cost a small fortune? How can I really sort of get to grips with implementing such an approach, in my organization? What would you say to those conceptions or even misconceptions from your perspective?
Yep. 30 years ago, yes, it's very expensive. It costs millions of dollars just to have the infrastructure. Today, I would say it's not a matter of if, it's a matter of when. If you look at your phone you use today, there's facial recognition. The phone today is what, $500 to $1,000. Yes, it's still expensive for a phone, but compared to 30 years ago, it's just a fraction of that. Now, also, some of this AI machine learning technology is open source. You can get it readily available, prepackaged. Now, you have to have some sort of math background and statistical background to be able to interpret and apply the right algorithm so you won't hurt yourself. But by and large, you don't need to have a team of PhD, right? You probably need a data engineers for data architecture related, a statistician or mathematician. These can be college graduate, right? Because math is math is math. It's been around for years. It's how you apply the same algorithm to the problem at hand. So from that standpoint, I would say it's very affordable. Universities are teaching that today. There's technology incubator that helps also solve that. So the it's wide open in terms of the availability of technology and the resources at large now that you can take advantage of.
And just on that, interesting you mentioned there about people, about different skills, and you also mentioned college graduates and everything else, because obviously one of the challenges in our sector is, the stacks of work coming up, from a UK perspective. I know in America, with Biden's $1 trillion infrastructure program, there's going to be loads of opportunities for the sector. I'll rephrase that, a massive responsibility on the that employing technologies like AI and big data give us an opportunity to showcase our industry as even more technical advanced than maybe many others. And is there an opportunity there to bring in new people with new skills into the sector?
Yes, there is. So, for example, take me for example. I came into the AEC industry with BST Global. Been in this industry 3 years, but I've been doing this for 30 years across different industry. Math transcends us all, right? So it doesn't lock itself in just AEC. So hire the right software architects and software engineers, just like in the AEC, we have architects, we have engineers. The same thing applies on the software side of things.
Okay, well, thanks for that, Hank. You've certainly demystified a lot of what we've been talking about here, and for that, I thank you very much. Do you have any closing remarks, that any message that you want to get out there just before we close today's event?
Yeah, I think that the one takeaway here is that AI and machine learning is here to stay. So again, it's not a question of if, it's a when. And I think if you deal responsibly and be very outcome driven from day one and start up small and evolve as you come along and involve the human aspect of it, I think you'd be very successful in its use and its application. And thank you for allowing me to speak today.
Well, thank you very much as well, Hank, for that. And I just want to remind people that if you do want to reach out to the good people at BST Global, then there's the contact details there. They'll be on our website later on as well. It's Koskun Tuzgol, and all his details are there for you to contact him. I've really enjoyed listening to what Hank's had to say, and I really want to thank him. I didn't say so at the beginning, but thank him for getting up extra early because he's been logging on from Tampa in Florida. We shouldn't have too much sympathy for him because it's very warm over there compared to certainly where many of our people are watching this from. So I just want to say a big thanks to Hank Tran and also to BST Global for generously making available their experience and expertise. And do get in touch with them if you want to start this journey in AI. It just remains for me, Andy Walker, editor of Infrastructure Intelligence, to say thanks very much for everyone for watching. And we'll see you again in the not too distant future. So thanks very much for that. Bye-bye.